Hello and welcome back to Learn Math by Example. Today, we'll be covering arithmetic series and maybe a bit of arithmetic sequence. This concept is incredibly powerful, helping us understand patterns in finances, growth, and many other real-world scenarios. First, let's take a quick look at today's list of concepts. We'll define arithmetic series, explore sigma notation, and visit the general formulas. Then we'll be solving a compelling IB style problem. Imagine this: an ambitious IB graduate, fresh out of school, lands her dream job. Her starting annual salary is $40,000. But here's the exciting part: each year, her salary increases by a fixed amount of $2,500. She plans to work for 15 years. Our challenge is twofold. First, we need to find out what her salary will be in her 10th year of employment. And second, we'll calculate her total earnings over the entire 15 years of her career. Sounds like a problem tailor-made for arithmetic series, doesn't it? Now, let's break it down. Now, before we start with the problem, let's lay down the foundational concepts. First, what exactly is an arithmetic series? Well, it starts with an arithmetic sequence, which is a sequence of numbers where the difference between any two consecutive terms is constant. For example, consider the sequence 3, 7, 11, 15, and so on. Notice that each term increases by 4. This constant difference, 4, is called the common difference, denoted by D. An arithmetic series is simply the sum of the terms of an arithmetic sequence. So instead of 3, 7, 11, 15, we'd have 3 plus 7 plus 11 plus 15, and so on. Next, sigma notation. Represented by the Greek letter capital sigma, is a concise way to express the sum of a series. The notation looks like this: sigma from k is equal to 1 to n of u of k, where k is our index, starting from the lower limit, usually 1, up to the upper limit, n, and u of k is the general term of the sequence. For instance, sigma from k is equal to 1 to 4 of 2 times k plus 1 would expand to 3 plus 5 plus 7 plus 9. This notation is super important for IB exams, especially when dealing with longer sums or defining patterns. Finally, let's talk about the general formulas. These are your best friends for arithmetic series. For the nth term of u of n, the formula is u of n is equal to u of 1 plus n minus 1 times d. This formula, along with all others where we are about to discuss, is thankfully provided to you in the formula booklet. Here, u of 1 is the first term, n is the term number, and d is the common difference. Remember, n represents the position of the term. Then, for the sum of the first n terms, or S of n as a shortcut, we have two incredibly useful formulas. The first one is n over 2 times 2 times u1 plus n minus 1 times d. This one is perfect when you know the first term, the common difference, and the number of terms. The second sum formula is S of n is equal to n over 2 times u1 plus un. This is more efficient when you already know the first term and the last term. Both of these formulas are clearly listed in your IB formula booklet, and they are very important. Knowing which formula to use can save you precious time in exams. Now that we have our definitions and formulas, let's put them to work and solve the ambitious graduate's earnings problem. First, in question 1, we have to know what is her salary in the 10th year of employment. Now we need to find the 10th term of an arithmetic sequence. From the problem, we can identify our key values. The first term u1 is her starting salary, $40,000. The common difference D is the fixed annual increase, $2,500. Now here they said constant increase. This is why we say that this is the common difference. And we are looking for the salary in the 10th year, so n is equal to 10. The formula in this case is un is equal to u1 plus n minus 1 times d. We replace our values in this formula, so we get u10 is equal 40,000 plus 10 minus 1 times 2,500. After evaluating this expression, we find that u10 is $62,500. Therefore, her salary in her 10th of employment will be $62,500. Now, moving on to question 2, we need to calculate her total earnings over the first 15 years of her career. Here we need the sum of the first 15 terms. Our U1 is still 40,000. D is still $2,500. And now N is 15, so we are looking for S15. Since we have U1, D, and N, the most direct formula for the sum of the n terms is Sn is equal to n over 2 into 2u1 plus n minus 1 times d. Let's plug in our numbers. S15 is equal to 15 over 2 into 2 times 40,000 plus 15 minus 1 times 2,500. Evaluating this expression either by hand or using GDC, depending on whether you are doing it as a paper 1 question or as a paper 2 question, S15 is equal to 862,500. So her total earnings over the first 15 years of her career will be $862,500, which is impressive. And there you have it. From a simple starting salary to significant total earnings, Arithmetic Series provides the tool to solve such real-world financial projections. Mastering these formulas and understanding their applications will give you a strong edge in your IB exams. To get more practice and solidify your understanding, you can visit our website, samshub.com. There, you will find free lessons with lots of exercises. If you know anyone who would need help in his homework or support in writing his IA, you can also direct him to our website. The link is in the description below, along with additional resources. Don't forget, discussion is a crucial part of learning, so if you have any questions or comments about this lesson, feel free to leave them below or on our website. We reply to them as soon as possible. Join us for our next lesson, where we'll explore more examples on arithmetic sequence and series.